we have almost reached to the end of partial derivative function topics. If you can remember, during the first time we learned on partial derivative, we learned how to derive the first partial derivative, second partial derivative, and mixed partial derivative, right? However, up until this point, we have only used first partial derivative. So, when do we need to use the second and mixed partial derivative? This is where we are going to use the second and also mixed partial derivative in a subtopic known as Hessian function. Right, we have Hessian function. What is Hessian function? Right, this is the formula of Hessian function. You can look at these notes to see how can they derive this function. Okay, so what's the one that we're going to focus now is on when to use Hessian function and what is the purpose of Hessian functions. Okay, to talk about Hessian function, we first need to understand another terms in this known as stationary point. Okay, stationary point is a point in one graph where the gradient equal to 0, meaning that there is no slope, right? If you look at this example of graph, we can say that a stationary point is a point that is will have slope equal to 0, meaning no slope. So for this one we have a slope, right? We have a slope. So if we try to zoom in, we might have a stationary point here, and also here, and also here. Those where slope equal to 0, right? The same goes to here, right? So in stationary point, there are certain kind of stationary point, okay, that we're going to discuss more later. Okay, so to use Hessian function, right, we first need to look for a stationary point. Okay, we are going to look for a stationary point in one graph, and if we have a stationary point, we can later use by the way, stationary point later will be we are going to discover it, and we are going to obtain it in the form of coordinate. So where is the stationary point? For example, for this one, so the stationary point maybe 5, 3, let's say. So it depend on for this case x, y, z, right? So the coordinate should be x, y, and z. So for 2-dimension graph, we will have a coordinate x and y as the stationary point. So we are going to look for the stationary point, which is just a coordinate that pinpoint where at what point there exists a slope equal to 0, and then using Hessian, we will be able to determine what kind of stationary point that they are having there without even need for us to draw a graph. So if you look at this, you'll see that, okay, if the Hessian is less than 0, right, the stationary point is known as a saddle point. I will talk about that more later. Alright, if Hessian is more than 0, okay, and we look at the second partial derivative, and both of x and y is less than 0, and the stationary point is maximum point, is known as a maximum point. So we are going to talk about more about that later. And if this x and y, second derivative of x and y is more than 0, the stationary point is known as a minimum point. So basically, and if Hessian is equal to 0, the test is fail or no conclusion. Okay, so basically, in this subtopic, we are going to learn on how does a function, a graph for a function look like without even drawing a graph. So we are just going to imagine it through finding out the stationary point and determining the nature of the stationary point by using Hessian. Alright, we are going to talk about that in our next video. We are going to discuss exercise do we have exercise here? Yeah, 5.8. Okay, so thank you.